Hi, my name's Gavin. I am at the final stretch of my Calc BC years in AP with my favorite calc teacher, Mr. Allen. And Mr. Allen gives us this cool project where we get to make a mock free response question that pretty much mimics what would be on the AP exam. So if you're here watching this video, hopefully you're preparing for the Calc BC AP exam, or maybe you just like some infinite series free response questions and you're really trying to challenge yourself. And hey, to that I say go you. So I chose infinite series because personally I suck at infinite series. They're the hardest thing for me to grasp. So I thought it'd just be fun to make a infinite series a mock AP question. So I just created this question, so let's get right into it. So the Taylor series of a function f of x is given. The summation is n equals 1 to infinity of negative 1 to the n, so it's an alternating series, times x minus 1 to the 4n plus 4 all over n plus 4. And then I also give the first four terms of the alternating series. So on the AP exam, they might ask you to do a couple things like determine the radius of convergence for the Taylor series. And if you're just now seeing this problem for the first time, I recommend you pause, try to figure it out, and then at the end, we'll go through the rubric real fast. So then next, they might ask you to determine the interval of convergence for the Taylor series. So that may rely on your first answer. So then after you've done that, you write the Taylor series for f prime of x, along with the first four terms of f prime of x. And now that you've done that, you also, at the end, the big curveball, the hardest one of all. So it gives you the Taylor series for ln of x, and it's n equals 1 to infinity. At negative 1 times, or negative 1 to the n minus 1 times x minus 1 to the n over n. And then with that Taylor series for ln of x, it has you write the fourth degree polynomial for g of x, which is ln of x times f of x. So this one was a curveball for me. I had to remember how to do this. So let's get right into the rubric. So here's just a little summary of the question. So when you look at the radius of convergence for the Taylor series, you just ratio test should pop into your head when you radius of convergence, ratio test. That's just, they both start with R, so that's what really helps me remember. And then here's the ratio test. So yeah. And then once you plug in our series or our Taylor series for the ratio test, you'll end up getting this equation right here, and it'll reduce down once you do all the algebra and everything to just x minus 1. So when you do x minus 1 to 1, you just get that the radius of convergence is 1. Sorry, I just ate dinner and it's not going down too well. So for the rubric on this, it'll give you 2 points. 1 point for setting up the ratio test, showing that you know what you're doing. And then the second point is for finding the radius of convergence, which also shows you know what you're doing. But when you get points for setting up the ratio test, so even if you don't know how to do the algebra, you can still get the points for trying the question. So just try the question. You might get a little freebie, set up the ratio test. And then B was find the interval of convergence. So you want to find and check the endpoints for the interval of convergence. So since it's x minus 1 on the inside, we know that the center of the series is at 1. And since the radius of convergence, radius of convergence is 1, the endpoints are 0 and 2. So now you need to know how to determine if those endpoints are included or they converge or if they diverge. So to do this, you can use the alternating series test, which if you get an alternating series, or if you set it up as an alternating series of the summation of negative 1 to the n times a sub n, which is just this chunk right here, then the limit as n approaches infinity of a sub n has to equal 0, and it also has to be decreasing for it to converge. So at x equals 0, when you plug 0 in, so 0 minus 1, you just get -1. And since -1 is to the 4n plus 4, there's no way that that exponent is going to be odd. So since the exponent's always even, since you can multiply anything times 4 and it's going to be an even number, and then plus an even number, that's just even. Since it's always even, it's always a +1 on the top. So +1 on the top, as n goes to infinity, that's just going to get closer and closer to 0. So the limit as n approaches infinity is 0. And then since it's just 1 and as n approaches infinity, the denominator is just getting bigger, and that's the only thing that's happening, you can also say that it is decreasing. That is, a sub n is always greater than a sub n plus 1. So therefore, by the alternating series test, you can determine that x equals 0 converges. And then x equals 2 does the same thing. So except instead of having a -1, it's a +1. So when you put in 2, 2 minus 1 is just 1. And there's no way you're going to get a negative number out of exponent of 1. So that also converges the same exact way. So since both 0 and 2 converge, they're included in the interval of convergence with those brackets, and that is the answer. So you'll get 3 points, one for finding the endpoints, one for using the alternating series test, and another for stating the correct interval of convergence. Straightforward. Big stuff, big brain. So then C was to find f prime, write the Taylor series for f prime with the first 4 terms. So the Taylor series for f prime is just, use the power rule. Pop the exponent into the multiply the exponent times the whole thing and then subtract 1. So, hardcore, easy. And then to find the first 4 terms, you just, you plug the number. You plug in 1 for n, 2 for n, and just solve it. Or if you really want to, you can use these first 4 terms and then just take the derivative of them, because, that works too. So the points on this one, to find the general formula for f prime, which is that, you get 1 point. And then to find the whole first 4 terms of f prime, that is also another point. And then the last part, the real curveball. So find, it was write the 4th degree polynomial for g of x, which is ln of x times f of x. And then it gives this Taylor series for ln of x. And so first you need to find the first 3 terms of ln of x, which just n equals 1, n equals 2, n equals 3. Plug it in and you'll get these first 3 terms. And then how I found g of x is you need to take these first 3 terms and these first 3 terms. So the first 3 terms of f of x and the first 3 terms of ln of x. And then there's a special rule. I don't know what that special rule is. So what I did was I just distributed them and used distributive property and ended up finding that the first 3 terms after distributing was these first 3 terms. So on this one, you'll get a point for having the first 3 terms for ln of x, since they're not given. And then you'll get another point for the first 3 terms of g of x. So even if you don't know how exactly to multiply out the power series, because that can be a little confusing, you can still get points if you just start working on the problem, which is finding the first 3 terms of ln of x. You can't do anything without the first 3 terms. So that's about it. If you have any questions, put them down in the comments. I know I tried to make this a little quick because it's hard to study for AP exams and you don't have that much time. But anyway, thanks for watching. Mr. Allen, I know you're seeing this, and I tried. I put work into this. I hope it's good. But thank you. Have a great AP test and a great summer after the AP test.